The procedure to carry out linear static analysis of a thin circular plate using HyperWorks 2022 and solver optiStruct is demonstrated. The circular plate is 250 mm radius and 5 mm thickness. The plate is made up of structural steel having properties as Young's modulus, 210, 000 MPa. Poisson's ratio, 0.3. Density, 7.85 times 10 to the power of negative 9 kg/mm3. The edges are fixed and a pressure of 0.2 MPa is applied at the top surface. Maximum dilection calculated using close from solution and FEM is compared. Results are as analytical, 2.53906 mm. FEM, 2.545 mm. Steps involved in linear static analysis is shown here and grouped into 5 categories. Model preparation, which involves creating geometry, meshing, creating material and assign material to components. Creating pressure load. Creating BC fixed end, the edge of the circular plate is fixed. Creating load step, create load step, linear static. Followed by running the model and viewing results. .hym and .fem files can be downloaded from https://www.sfem.in. Model preparation. Creating geometry. Go to menu. Click on geometry. Click on circle from the shapes icon. Left click in the workspace and drag the mouse. Click on the fill shape that will make its surface. Enter the value of radius, say 250 mm. Press F on keyboard to fit the dish. Right-click in the workspace and click on the green tick. Generating mesh. Go to menu, click on the mesh. Select General 2D Mesh. Select the disk by clicking on it. Enter the value of mesh size. Click on the mesh. Mesh the sizes can be adjusted by putting appropriate number of elements. Right-click on the workspace. Click on the green tick. It completes meshing. Creating material. Main menu, click on the model. Click on materials, the material form is opened. Enter a material name like ISOMAT. Let the card image to be MAT1. This card image is for isotropic material. Retaining the default values of material properties. Young's modulus value as 210,000 MPa. Poisson's ratio as such and also 0.3. Density. 7.85 times 10 to the power of negative 9 ton/mm3. Close the form. Creating properties. Click on properties. Enter a name. Card image, shell. Browse the material defining property. Enter thickness of the beam, T equals 5 mm. Close the form. Assigning properties to components. Click on the small arrow. And click on the 3 dot next to property and select the property. Click on the component. Select the component in the workspace. Click the green tick. Now it completes the model preparation. Creating BC fixed edge. Right-click in the model browser. Create. Load collector. Enter a suitable name. Leave other entries of the card to default. Click on Analyze. Click on BCS. Click on Constraints. Select Nodes/Nodes. Select by Geometry. Click by Lines. Select the edge of the circle. Click Add to Selection. Change load types to SBC/. For fixed boundary condition, set all DOF 0. /. Click Create. Click Return. Fixed end BC completes, now creating pressure load. Creating pressure load. Right-click in the model browser. Create. Load collector. Enter a suitable name, pressure_load. Leave other entries of the card to default. Click on Analyze. Click on Load/. Click on Faces push button. Click on the top face of the disk. Enter -0.1 in the magnitude field. Change the load type to Plode. Click Create. Click Return. Creating load step, linear static analysis. Right-click in the model browser. Create. Load step. Enter a suitable name. Analysis type, linear static. SBC, point to fixed_BC. Load, point to pressure load collector. Close the load step form. / Running the model. Click on the Analyze from the menu. Click on the Run, the small arrow. Choose a file name for saving the FEM model. Run options change to Analysis. Click on optiStruct to run the model. Viewing results. Results from console solver view. Click on Contour and apply. The max deflection and from FEM and close form solution are matching well. .hem and .fem files can be downloaded from https://www.sfem.in.